Alrighty guys, welcome back to Michelle's version of calculus, and today we'll be talking about types of discontinuities for unit 1.10. Alright, so here are pictures of our three different types of continuities. Our first one we have on the far left is what we see as a removal or a remove is okay. Alrighty. So the first discontinuity that we have in our far left is a hole, which is basically exactly what it sounds like. It's literally just a hole that is stopping a function. All right, guys. And so this is a type of, let me write it down. This is a hole, and holes are a type of removable discontinuities. And it's called removable because basically you're able to plug the hole whenever you and it's called removable because you're able to plug in the hole when you want by just changing up a function. Alrighty, you can take it in and out, and just let it be known. I'll explain it in the next one, but this is not considered a jump discontinuity because there's no real break in the line. A jump discontinuity is over. Let me pick a different color. A jump discontinuity is over here. This is a jump where you can actively see that there is a real gap and jump between these 2 points here. Alright, jump discontinuities are non-removable. There is no way for you to actually, kind of plug in a jump discontinuity. So this is a non-removable type of discontinuity. And the last form is a infinite. And when you have an infinite discontinuity, that is basically just an asymptote. And asymptotes, of course, are very much so non-removable at all. Alrighty? Yes. Cool. Alright, so we're going to head into an example over here, which I really hope is more or less a review for you guys. But whenever you want to find, or how about this? Whenever you want to find types of discontinuities with just a function like this one here, you can do it by knowing the specific ways for you to be able to tell. Alright, so I'm going to go ahead. First thing first, first step is to, if you can, factor out what you have. So we have x minus 5 on top, can't be factored anymore, but this x squared minus 7x plus 10 can be factored. And it can be factored to x minus 5 and x minus 2. All right, this is what it factors out to. So let me try to use the same colors here. So whenever you have a hole or a removable discontinuity, to be able to tell when you're doing math like this, whichever term cancels out on numerator and denominator is a hole. Means there is a hole here. So we know that we have a hole at x equals 5. Remember, not negative 5, x equals 5. All right. And to find your vertical asymptotes, you want to set your denominator equal to 0. So, and please use, when you're setting the denominator equal to 0, you have to do this after you've gotten rid of the hole. After you've canceled out all the terms, you use this. And the reason why x equals 2 is a vertical asymptote and why we use the denominator for the vertical asymptote is because you cannot have 0 at the bottom of a fraction, and that is because it will become undefined. So, yes. Alrighty. That is basically all for that example. But another thing I want to point out, I guess this goes more along the lines of continuity, but let's say you have x squared minus 6x plus 5. All right, let's say we have that for our lovely little thing here, and you're asked to find the discontinuity of this. It's important to note that, let me type this up and out, that that a polynomial, or let me not say that quadratics are continuous everywhere. So there is not any place on here where you will have a discontinuity. So anytime you see a question like this, it very much so is a trick question, and the answer is no discontinuity. Alrighty, that is all for 1.10.